Alright, welcome to a new week. So we're going to continue with classes now. We got all the way down here. We were working on a point class, and we decided exactly what we wanted to put inside of it. We have to say class point to define the type, and then an interesting keyword called public that we'll talk about later, and we need to give the variables that live inside of this type, the member variables, and then now the new cool thing is methods or member functions. So we can negate a point. We can add 2 points together. We can scale a point by some scalar c. And this is how we could run our program. Okay, so we stopped before I actually wrote this program, so now let's do that. Dun dun dun. Let's just call it points.cpp. So, actually, probably for better reasons, I didn't make a file, did I? Yeah, let's call it point.cpp for reasons. And so let's do exactly what we said we were going to do. I would like to make a program that works in the following way. I want to be able to define some points and do cool things to them. Be like, here are my points. X is going to have P's X is 1, P's Y is 2, and let's do something similar for Q. Okay, maybe it can be, I don't know, 3 and 4. And then we can negate P, and we'll keep Q how it is. Maybe perhaps we can scale Q by, I don't know, 2. And then what was our other one? We can add points together, so then we can be like, point sum equals p.add q, or equivalently, q.add p, and those will add them together and give back a new point. That is the sum of them. So, in theory, right now, what should p be? What should q be? Okay? And what should sum be? P should be this coordinate. So it was originally 1, 2, but then we negated it up here, right? So our member function should make its x equal to -1, y equal to -2. Q should be, well, it started out with 3, 4, and then we scaled it by 2, so we changed everything by a factor of 2, so now it's 6, 8 for x and y. And then the sum of those two should be this. Sum should be, well, whatever their x coordinates were summed together, so 5, and whatever their y coordinates were summed together, so 6. Okay? So if only we could print those out, we could say something like, cout p, and then a open parenthesis, and then p.x, then comma space, p.y, and then close parenthesis, new line. Okay, so that's p. Then we'll do the same for q, and then we'll do the same. Then we'll do the same for this, and we'll change it to sum. All right, so that should print them all out. And in theory, if we do everything right, we'll get those values. Okay, so now let's make our point class. It's a new type. It's called point, and so now I can make things of it. I can make a p and I can make a q. And public things in this class are things that the user gets to see and use. Are, well, my member variables, the x and the y that belong to a point. So when I say point p, semicolon, I just made a point in memory with room for an x, a little box for an x, and a box for a y, and then all the methods associated with it. Okay? That's what happened. Same for q, it got made. And so we need those member variables. And I think it was doubles, right? Double x, double y. So every, just like structs, this point will have an x and a y associated with it. And now we'll get to the methods, okay? So these are the member variables, and these will be the methods, or member functions. Alright, so, oops, it doesn't want to move over. There we go. then we need to make our 3 methods that you can use from the point class. What operations can you do on points? You can negate, you can add, and you can scale. Okay? So we have void negate, point add, and then we have another point that we could be giving. So point p2, and then we have void scale, okay, by a factor c. Okay, so let's talk about these. So negate should take our current objects, x and y, and negate them. Okay, so let me make a new slide to show what's about to happen, what we would like to happen. So when we say point P, and we say P.x equals 1, P.y equals 2, in memory, we will have made a thing called P with x's and y's inside, and the x was 1, and the y is 2. And the second we say P.negate, we say, hey P, go and negate yourself. So after running this, it should cause x to become, sorry, not 2, x should become -1, and y should become -2. Okay, that's what negation will give to us. And so it's just going to change the member variables, and we have access to those. So every method has access to the member variables, yeah. Okay, to the fields. And that means that this function, this method, got called like, I don't know, z.negate for some point z, whichever one we told to negate itself. And now, therefore, whenever you say x inside of this method, gets z's x coordinate, not somebody else's, because we called z.negate. So saying x now works on the current object that we're acting on, so it's going to be z's member variable. So saying x, we have an x, it's up here, it belongs to every point. The point we're working on is the one that got its negate called on it. Okay? So sorry to spell it out like that, that's just important. X equals -x. Same for y. Okay, so that's negation, and it doesn't have to return anything because it just needs to change the current object. Okay, so that's that. And so now we can do the same for all these other ones. This point P2, it can be a constant because we're not going to change it. It can also be a reference. Save some memory. Now this one's going to return a new point, okay? So this got called like, I don't know, z.addW, and so we want to add our current objects coordinates, z's, x, and y, because it got called like this, z.addW. So it's acting on the point z. Take the z's, x, and y's and add them to w's, x and y, and give back a new point, okay? All right, so the point that I'm about to return is this one. I'll call it ret, and its x is going to be equal to my current object's x, so just x, plus the other object's y, p2, not y, okay? Because that's the other object, we call it p2. So add my current x, this is always from the point of view of the object that you're calling this method on, okay? It's always from z's point of view, if it's z dot, to p2's x, okay? And then we'll do the same for y. Oh shoot, sorry, this is supposed to be x. There we go. And then we need to return the answer, because we promised to return a new point. Okay, so there's that. And then finally, we will work on this scale method. All right, so in order to scale, we got called like this. We said, I don't know, p.scale 2. And so we're acting on p right now. So inside, if we say x and y, we're working on p's x and y. P scale 2 is going to multiply the x and the y by 2. So -2 now, -4 now. Okay, so that's what will happen to this particular p in this slide if we scale it by 2. Okay? And you can scale it by any double, but hopefully it makes sense to you that, all right, the x needs to change to whatever it was times c. Same for y. All right? So that, in a nutshell, is our class. We have defined a point, what it means to be a point. Well, it has x's and y's, but also it has the ability to negate itself. It has the ability to add itself to another point, and has the ability to be scaled by some factor. Okay, so hopefully this all makes sense. We gave them values, p and q, our points. We did stuff to them. We added them together, and we should, in theory, see the right answers now. Okay, so oops. Gotta do this. Okay. And oh man, do we get the right answers? What, -1, -2, 6, 8, 5, 6. And the reason for that is, well, all these things started with the values that they were given. Q.x was 3, Q.y was 4. We scaled it by 2, which called this function. It took the x of its current object, which was q, because we called this method on q. We scaled its x, which was 3, by 2, to make 6. We scaled its y, which was 4, by 2, to make 8. And then we print out q. Suddenly, its x and its y are 8. Okay? So I guess the key takeaway is the variables that live inside the method are always the objects, okay? Or what are visible. Okay? So if you say p.negate, you're now acting on p's x, okay? You're acting on p's y inside of the method, okay? That's what I want to get you to take away from this. So you can just say x, and you're getting p's x because you called it on p, okay? I'll say that below here. Okay, like p.negate. All right, hopefully that's all making sense, and we're all on the same page. So that is classes in a nutshell. Let me see how we're doing for time. Not too bad. And, well, this is all well and good, but this can get very large, okay? We can make a class, we can define all its methods inside of that class, but that is not the right way to do it. That's the lazy way. All right, so I taught you the lazy way first. Let's talk about the proper way to do it, to split everything up. Okay, so I just implemented all the methods inside the point class. Okay, that is a problem because this could get very large. It'd be nice though. Split up the declaration of the class. You can see where I'm going with this, and the implementation, which means .h and .cpp. All right, so let me show you how to do that. But first, let me just split up the declaration and the implementation in the same file. Okay. If you're like in between being lazy and not lazy, you can do this. Okay, so the way that you do it is you bring all of these methods out. Or actually, let me show you the process. Let me copy this. So this is point class. lazy implementation. That's CPP, so that's the old one. Now we've got it saved for you, and I'll implement everything again in this same file now. Alright, so we're going to take the methods, we're going to take them out of the class, okay? We can bring them wherever we want. We can put them below main, in fact. Okay? So, here they are, chilling down here now. Cool. We just need to tell the class that these methods exist, alright? Alright, so we just need to give their signatures just like you would in a .h file. So we gotta say, alright, there's a negate method. There is a there's an add method. And there is a scale method. Okay, so we just need to say that they exist, and we can define them later. And the one key thing is, this is not quite going to compile because this is just a normal function called negate. It has no clue that it's living inside of the class. Okay? A class. This could work for anything. Once you implement the methods outside of a class, you need to be very specific about whose methods they are. Because they just look to C++ right now like normal functions that don't work on classes at all. So you need to say that this is not anybody's negate function, this is point's negate function, okay? So you need to say the name of the function gets prefixed with class name : and you can read the : as ''s. There. Now it's going the right way. Okay, read it as ''s. It's points negate function. Yeah. Dun, dun, dun. It's not add. It's points add function. It's not scale, it's points scale function. Okay? And so now it's happy, and it'll all work. That's the one new thing. And so now, this looks a whole lot cleaner. All the user needs to see is this stuff to know how to use your class. Ah, shoot. Escape. Abort. Well, I compiled it. There. And it works just fine still. Okay? Now we can go even further. We can split it up into .h and .cpp files. Okay? Dun, dun, dun. So let's make a point library now. I'll save the old version to point slightly less lazy .cpp. And so what we're going to do, let me make a folder now. Point library. And I'll move the, I'll copy the point slightly less lazy into point library, and I'll call it point.cpp there. Alright, so let's go inside of the point library folder, and we'll say, alright, point.cpp, we need a couple more files now. Point.cpp, we have that one. We also need point.h, with our default kind of stuff that blocks infinite inclusion. And here we're going to give the declaration of the class, just as normal. So declare in point.h, and then we'll implement in point.cpp. So the main function needs to go away. And we'll include our header file so that it knows, oh yeah, there's a point class and we're implementing it. And then we just need to make our file that has a main function. Oops. I'll call it main.cpp perhaps. And then we'll include our library so we can use it. And that is all well and good now. Okay, so we got three things. We've got our implementation of all of our methods. We've got the declaration of our class. Let me refresh this. We've got the declaration of the class itself with all the stuff that it has. Then we've got main.cpp that actually uses the points that the point library that we made for ourselves. Okay, and so to compile this, we need to say g++ standard equals C++17 as usual. And then we need to give both implementation files, so main.cpp, point.cpp. Okay, so we can say -o main perhaps. Whee! All right, so now we do this, compiled it to something called main, and again, it does the exact same thing, but everything is nice and logically separated now. Okay, so now I can pull some more of the curtain off of your eyes. So we used public everywhere, and that means a few things. By using public in our class, we controlled the access to our methods and member variables. And we didn't really control it, we just gave unfettered access to all of them. So anything after public is visible to the user outside of the class's implementation. And the issue is, well, our users, we don't trust them. They can easily do something bad to all of our stuff. So perhaps you only ever wanted to allow points that existed in only one quadrant of a graph. So maybe you only want to have points up here. At least to start. And obviously, if I say point P, P.x equals -2, suddenly, because I had access to X, I get to make this thing that you wanted not happen. Okay, so I can touch X because it was public. It was public. If you don't want your user to touch something, you'll make it private. Okay? Okay, that's all. And that is going to allow us to make it so that some things the user doesn't have access to. All right? And, well, that's going to change a few things around. And let me go back to this point slightly less lazy.cpp and copy that and just work in that one. That's a bit easier for me to do right now. Copy that into something called, what are we about to do? Point with private member vars.cpp. Alright, so this is my new file. It's got everything we had. And so now I'm going to have private member variables. And public can be all the methods. So the user can access everything under here. The user cannot access any of these things. And you can put methods in the private section as well. But normally, you put all of your member variables as private. And I'm going to show you that this allows you to make it so that you cannot initialize a point in a weird way. So this will not compile, okay? I cannot access X and Y. This won't compile anymore. Oh shoot, sorry. I'm in the wrong folder. Okay, here are all the errors that we get because we're trying to access X and Y. P.X, double X, no. These are private. You cannot access them outside of the class. You can access them within all of these methods, because that's part of the class. Of course, you'll need access to them there. But outside, when you're like in main or somewhere, no, you don't get access anymore. This won't compile. So you can comment it out, but now you have no way to like initialize a point. What? Yeah. Now this will work. Not quite though. It still can't print. So again, down here we're using X and Y. If we comment that out, it'll all work now. We can call negate, scale, and add, but we can't do anything else. Okay, so this program does nothing now. Okay, so I will comment this out. There will be a better way. And this. Like that. Okay, so the issue is we need a better way to initialize that doesn't let users do silly things, and also we're going to need another way to print, won't we? Okay. That is wonderful, and I think, I guess I'm going to have to leave us there for now. So, there is a way to solve this, but that will be in the next section. Alright, so before we get anywhere else, let's test our point class. This is very important to do, and I'll go back to the library for that. Whee! And, alright, let's start editing main.cpp. Let's test that our points do the right thing, okay? So, we're essentially writing one big test right now. We made a P, we made a Q, but let's make it an actual test. Let's be like, all right, assert true, bool B, string description. I'm gonna need string because I'm using strings. Oops. Don't talk and type at the same time. So if not B, we say failed. Uh-oh. Otherwise, we say passed. Okay, and yeah, that'll work. So now let's convert this to a test. Okay, so our test is, well, these should have all been equal to -1, -2, 6, 8, and 5, 6. So let's write this test. So assert true p dot x equal to -1 and p dot y equal to -2. And we'll call this test p. Okay, and then we'll do the same for q and sum. All right, so what should q be? Six and 8, and then sum should be 5 and 6. And that should do it. Test q, test sum, and really this should be a test function. So I'll make one. I'll call it void test point and put all of this inside of it, and this is a valid test. Okay, we were almost there. We just need to spell it out for ourselves. And then I just need to declare the fact that this exists somewhere up here above main. And now we are set. Alright, so I made one test that tests all these things, and we ran it. We expect p.x to be -1, we expect p.y to be -2, and so on for q and sum. Okay? And obviously, because we printed it, it should all work. Darn. G++ standard equals C++ 17 main.cpp point.cpp-o main. And now we have some past tests. Now we could either make the tests wrong. We could be like, this was really 5, and now one of the tests won't pass. Or we can make our implementation wrong. But we have a correct one. Let's not change that. Okay. So that's testing, just to remember what that is. So the idea is recap of testing strategy. You write a small little mini program to do some things with your class. And then, in your mind, you run the program. And this lets you be able to tell, all right, is this doing the right thing? Because you know the proper values now. And then you compare using standard testing functions whether your expectation matched reality. Okay? And so that's essentially what we did there, and that's all I want to say there. Okay. Boop, boop, boop. So let's move on to some philosophy, and then we'll get fancy in just a little bit. So some things that we just learned, given this access control thing. We're going to fix everything and make private work for us in just a second, but we just learned about information hiding and encapsulation. So first of all, encapsulation is just the entire driving force behind people using classes. It works really well because you get to bundle data with the methods that operate on the data. For example, points not only hold x and y coordinates, but also, let's just spell it out then, but also it holds the operations that you can do. Okay, that's beautiful. That's something that's really nice about this object-oriented programming that we're learning about right now. And then we just learned about the concept of information hiding. So the user only gets to see just enough to use the class itself. So only the public stuff does the user ever get to see. Okay? And so the reason behind that, and I will show you in the next section, a good example, is that you can go off now, say that you make a method that the user doesn't get to see that works under the hood. Maybe your negate function, your scale function, calls another private method that does some fancy thing. You can go off and implement a better version of that function, of that method. And as long as the interface that you give to the user, all the public methods, as long as those still work and do the right thing, nobody's going to come with a torch and a pickaxe, or I guess it's more like one of those large forks. I don't know what they're called anymore. Pitchfork. There we go. That's the one. So nobody's going to come and hunt you down because you only gave some things available to the user, and as long as you don't break those, you're good. All right. So that's some philosophy for us, and now let's move on a little bit. So the first thing that I want you to remember is that string and vector are classes. You have done many a thing with strings and vectors. You have done the following. s.at 0. Get the first character, haven't you? You've printed that out, perhaps. You've done the same for vectors. You've done v.pushback 4, which modified the vector because it was the thing, it was the object that the pushback method was acting on. Oh shoot, it's all coming together. And this, the at method on strings, acted on the object s. Alright, so s is a class. Vector is a class. It's a special kind of class that can hold any type inside of itself. You'll have to wait until CSCI 41 to learn more about that. But I just want to show you that you've used classes already. They are not scary and horrible. You will be able to implement things just like this, and it'll make your life so much better because you have learned about both strings, C++ strings, and you've also learned about C strings, which suck, right? Those are harder to use. Strings are super nice. You can do like .find, .at, all these fun things. Whereas for C strings, which are not classes, you just have to pray that the C string library has what you need. Alright? So, classes are beautiful. They are the future. Object-oriented programming. Alright, so we're going to get fancy now. I'm going to throw up a bunch of terminology, and I don't want it to scare you, but there is quite a bit of it, and I'm going to give as many examples as I can. Okay, so we're going to get super fancy with classes in object-oriented programming. Okay, so remember, an object is an element, a value of a certain class type. So it was like our point, or a struct as well. It was like our point. So we can work on getters / accessors, setters, and mutators, and this solves the problem for private. Alright, that's a long sentence. So once you use private and you restrict access to your member variables, you start having to add public methods that can actually get those things. So for point, for example, you'll have getX, getY, and then to set things, you'll have void setX, setY. Okay, so these are called getters, or accessors. They access the X and they access the Y and give it back. And these two are called setters, or mutators. They change values. They don't return anything. Alright, so getters give back values of private member variables, which is nice if you want to do anything fancy with that. And then setters give back nothing, well, and they set the values of private member variables. And you might be thinking right now, well, this is stupid. This is just a roundabout way of using dot something equals something else. And the answer is yes. For a lot of classes, maybe you should be using the dot operator. You should make your private member variables actually public. But sometimes, when you want to restrict things, or you want to do some debugging, these will save your life. Okay, so let's go back to the first thing. I never want my points to have negative, to be set to negative things. Okay, so I can restrict that. Alright, I'm going to edit point with private member variables again. So we remember, once we make these private, we can't access them in main anymore. Oops. So we need to do the following. p.setX, -1, p.sety, -2, q.setX, 3, q.sety, 4. These will all still work. These won't work, but we can say get instead. just like that. All right. And we'll do the same for y. We'll replace p.y with .getY. Okay. I'll do the same down here. Cool. These will all work as long as we implement them. So we'll do that up here, and we'll make them public. And that should be enough. And then we just need to go and implement them. Do it down here. Okay, so get x just returns x. Get y returns y. These will set things, but in a special way. But before we get into that, remember it's points get x, points get y. So these are kind of simple, they just return the value. But the magic of private allows us to do the following. If d is negative, let's make it so the user can't set points to have negative coordinates. They can use negate if they want to, but they can't do it themselves. Okay, so we're restricting access to the user right now. We'll say, okay. If you try to give me a negative value, well, I'll set it to the positive version. Oh, sorry. Set my x to the negative version of d. Make it positive. Ha. And then otherwise just set x to d. Or actually, how about we do this? D equals negative d, and then down here we can do x equals d, no matter what. So now we can do the same for y. I guess we'll do this one. Y equals d. And we can even print out stuff. We'd be like, hey user, you messed up. Users always like that, of course. And so now, this idea of dot y equals something, we've encapsulated into a method. And oh man, is this going to save our lives? We'll say, you cannot have a negative x coordinate. You cannot have a negative y coordinate. So now, it's going to force p to be initially 1, 2. You see that? And then when we negate it, it'll become negative 1, negative 2. That's fine. So it actually does exactly the same stuff as before. But we are now watching out for the user. They tried to enter in negative 1 for x, negative 2 for y. We're like, not happening. Okay? So hopefully that gives you a sneak peek as to why this might be useful and interesting. Okay? And I think the last thing that I want to talk about is this const, and then we'll break for the next lecture. So we've talked about const as parameters. So that's saying, like, I don't know, void foo const int, I don't know, const string reference s or something like that. Const reference is something that we've talked about quite a bit. Where did I go? There we are. This makes it so that s cannot be touched. there's an equivalent thing for classes and its member variables. When you don't want a method to touch its private member variables. Then you'll say, you can put const after the method. Okay, so this doesn't really give you a whole lot. I'm sure you think that it doesn't really give you a whole lot right now, but it helps when you're testing. So for example, these get functions, they don't modify x. They don't ever modify y, they just retrieve them. Okay? So they should be const. And the way you make a method const is you put it right after the name of the method. Get y const, just like that. Okay? And you have to do the same thing down here. You gotta say const. You gotta say const. Well, this makes it so that you can't do anything silly, like, well, let me show you it working right now. It does the same thing. Let me show you it not working. By making this method const, the following cannot happen. Keeps you from doing silly mistakes. Oh. Error. Read-only object. Const makes the object you're working on that got its getX method called read-only. Can't do this. So it keeps you from doing silly mistakes, and it keeps you from having to check in your tests whether or not that's happening. Okay, so that's const. And so we have, let me just give you a quick recap of everything we've talked about today, because it was a lot. We have made a class. It's a type. A class then gives the name of the type that you're about to create. It makes a brand new type that you can then go and use with the name that you gave it. You can declare variables of that type. And they have their little boxes in memory with all the member variables inside of them. So every point holds an x, every point holds a y. And you can do things to these points. You can do all the public things to the points. You can negate them, add them, and give back a new point. You can scale your current point. You can access or set its member variables. And you can section off parts of your class that you don't want the user to be able to touch because you want to, for example, make it so that they can only set the class's member variables in a certain way with respect to a certain, like, guidelines, a set of guidelines. Okay, so private things for the stuff that you only want to be able to use inside of the class but never give access to your user. And then public is for all the stuff that you want the user to be able to use down in main or whatever function that they make a point in and do your point object dot something. All right, so we have come quite a ways this lecture, and I hope that it's all making sense. And then we talked about splitting up all of our classes to declarations. We say, all right, this is what a point class can do and what it has, and this is down here how it does it. So points negate function, this is how it's implemented. So you called points negate function on a certain point. You said dot negate on a certain point object. All right, this is how you change that particular object to correctly be negated. Okay, same for add, same for scale, and all the rest. Okay, that's points set x, not just a random set x function that's floating around outside the class. Okay, so I think that is all I want to say, and I will see you in the next lecture now.